Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k divided by square root of k is equals to 5, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. And here in the first method, we need to move this square root of k from left hand side to the right hand side, and when we move it into the right hand side, it will be written as k is equals to 5 times of square root of k. So further in the next step we need more simplification, and here we need to remove this square root sign. So for removing this square root sign, we need to take squaring on both of the sides. When we apply squaring, it will be written as k square equals to 5 times of square root of k and its whole square. And now in the next step we need more simplifications, and it will be written as this will becomes k square is equals to, here we need to apply the square separately on both of these two values, and it will be written as 5 square is multiplied by square root of k and its whole square. And now further in the next step we have this is k square is equals to, here we have 5 square and 5 square becomes 25, and this 2 and this square root are gone, and we get here k only. And now in the next step we need to move this 25k from right hand side to the left hand side, and it will be written as k square minus 25k, and this whole equation is equals to 0. And now you see here both of these two terms involve k, so that we will be take common k from here, and when we take common k we get the remaining values are k minus 25, and this whole equation is equals to 0. And now here in the next step we need to divide this equation into the two cases. The first case is we write k equals to 0, and the second case is we write k minus 25 is equals to 0. So this is our first root of the given equation, and from here we get the value of k equals to plus 25, and this is the second root of the given equation. So in this method we get these are the two values or two roots of the given equation, 0 and 25. And now in the next step we need to verify that is which of these roots are solution or which of these roots are extraneous root. So for verification we need to copy down given question statement. Here it is k divided by square root of k is equals to 5, and here in this side we will be verify k equals to 0, and in this side we will be verify k equals to 25. So here first we need to focus on k equals to 0, and here we substitute k equals to 0 into the left hand side, and when we put this value here it will becomes 0 divided by square root of 0 is equals to 5 or not. So you see here 0 divided by 0 becomes 0 divided by square root of 0 becomes 0 equals to 5, and here you see that in the left hand side we get this is 0 over 0 form, or in other words we just say that it is indeterminate form, or we call that it is undefined form. So if our left hand side is undefined form, so we say that both of the sides are not equal, and if both of the sides are not equal, this means that the value of k equal to 0 is not satisfied our given question statement. So we call that k equals to 0 be the extraneous root of the given equation. Okay, so this is the extraneous root because it does not satisfy our given question statement. And now here in the same pattern we need to verify k equals to 25, and when we verify k equals to 25 we put this value into the left hand side, and it will becomes 25 divided by square root of 25 is equals to 5. And further you see here we have 25 is divided by this is square root of 25 becomes here 5 is equals to 5. and we obtain this is 5 times 5 becomes 25, and we easily get 5 equals to 5. So this shows that both of the sides are equal, and if both of the sides are equal, this means that the value of k equals to 25 is satisfied our given question statement. So finally we conclude about that the solution set of this problem is k equals to 25. So this is the only one solution which we get here from first method. And now we need to move towards our second method. And in second method, we need to copy down given question statement here, so that our given question statement is k divided by square root of k is equals to 5. This is the given question statement, and here our second method is a very quick method, and here we quickly get the roots of this equation. So for this we first write this k as into the form of product of two square root terms in this way, okay, and it is divided by square root of k. You know that if we have a number a, we write it as square root of a multiplied by square root of a, okay. So according to this rule we write this k as in this form. And now here further you see that this square root of k and this square root of k are cancelled out by each other, and we obtain here square root of k is equals to 5. And here for the values of k we need to take squaring on both of the sides, and when we apply squaring it will be written as in this form. So this 2 and this square root are gone, and we get here the value of k is equals to, this is 5 square and 5 square becomes 25. So this is the value of k which we get here from second method. But in the first method we already verified that this value of k is satisfied our given question statement. So finally we conclude about that the solution set of this problem is k equals to 25. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.